Hello everybody. So here's a follow-up video to this original problem which I posted maybe about a week ago. Okay, this problem is about somebody who wants to mix these different alloys of titanium. All right, and we have one alloy that's 10% titanium, the other is 25% titanium. Okay, so that means that if it's 10% titanium, 10% of it is titanium, and the rest is something else that we don't need to worry about. All right. Same thing with the 25% alloy. 25% of it's titanium by weight, and the rest of it we don't need to worry about. Okay. What we need is to mix these together and get something in between. All right. You think if you mixed a 10% and a 25%, you get something in the middle somewhere, depending on how much of each of these you used. Okay. So we want 100 grams of an alloy that's 16% titanium. Okay, so the question is, how much of each of these should we mix to get something in the middle at 16%? And we want exactly 100 grams. Now, I gave you this hint in my original prompt about how I would like you to think about this. This is not the only way to think about it, but if you think about it this way, then you will really understand what's happening as you set up the equations and proceed to solve it from there. So I diagrammed it like this. I'm going to mix this and this together, and I'm going to get this. All right, X grams of a 10% alloy. I don't know how much of this particular alloy I'm going to use. That's the entire question. And Y grams of a 25% alloy. I say Y because I don't know. X, I don't know how much of this one. Y, I don't know how much of this one. But I'm going to get exactly 100 grams, and it will be 16%. So we get two equations out of this block diagram. On one hand, the amount of titanium in this plus the amount of titanium in this must equal the amount of titanium in the final mixture. All right? Just makes sense that the whole is the sum of the parts, and each one of these alloys has a certain amount of titanium in them. And those must add together to get however much titanium is in their final mixture. So when I write down this equation here as part of my setup, in this particular alloy, 0.1 times X is pure titanium. Right? That's what it means to say that 10% of this alloy is titanium. 10% of X is pure titanium. So that's this number. And then this one, 0.25 times Y is pure titanium. All right, so the amount of titanium in this and that must add together to be the amount in the final mixture. Okay, so if I have 100 grams and 16% of it's titanium, then 0.16 times 100 is pure titanium. So this first equation just says that. It says the whole is the sum of the parts as far as how much titanium is in each part and the whole. Okay. And then the second equation says that however many grams of this there are and however many grams of this one there are must add together to be 100 because that's how much you're getting. All right, so that's my second equation. So that's the setup. That's how you think about it. Now I'll pause here for a second. I want to remind you that in the videos that I post and I provide for you, I already posted one about an alcohol mixture problem. And that's no different. I mean, if you're mixing different alcohol solutions, okay, 15% alcohol and a 20% alcohol, that's the same principle as combining metallic alloys. All right, same idea. To give a percentage of how much of it is pure alcohol in the alcohol mixture problem or pure titanium in the metal alloy problem, it's the same idea. The whole has to be the sum of the parts in either case. So we wouldn't really think about these differently. Same concept, same thinking along the way, and I get, in the end, the same setup. Okay, so now let's solve it. The objective here is to solve these two equations. Let me write that down over here. So I take them and I just make one adjustment. And as I wrote it down up there, this was 0.16 times 100. That's 16. Okay. So I'm working with this. The way I'll solve it is I'll solve this one for Y, okay, and then I'll plug it into the other one. That's called substitution. You may see in some of the problems, it might say solve this by substitution. That's what we mean, is that we take one equation, we solve it for one of the variables. It doesn't matter which one. solved this one for y, but it makes no difference. And then we substitute appropriately in the other equation. So if I do that, if I put for this y right here 100 minus x, then it looks like that. Now I'm trying to solve for x. I distribute this 0.25, I get 25 minus 0.25x. This 0.1x and that negative 0.25x are like terms. They both have an x attached to them. They can be combined. We do that by just combining the coefficients. 0.1 and negative 0.25. That gives the x a coefficient of negative 0.15. Additionally, I move this 25 over there by subtracting 25 from both sides. 16 minus 25 is negative 9. Then I divide by my coefficient here to get x is 60. So what I want is, well, let's see, what was the x? The x was however many grams of the 10% alloy I'm going to use. So I want to use 60 grams of the 10% alloy. I'd state my final answer like that. How much of the other one? Well, the other one was y. So if I know x, I have to look back in my equations for an easy way to find y. And any equation that you see is fair game. I think this one would be easy to use. See, if I know x is 60, I could plug it in right there and I could figure out what y is. So y is 100 minus x. If x is 60, y is 100 minus 60. That makes it 40. So I want 60 grams of the 10% alloy and 40 grams of, well, y was the 25% alloy. Okay, so that's how we'll solve it. It might sound different when you read it initially compared to the alcohol mixture problem, but it's the same thing. It's the same thinking along the way, whether it's a mixture of titanium and an alloy or alcohol and some other kind of solution.